Hey, welcome back. In the last episode, I went through making a work object and sort of explained why you would want to use one. And then we put our tool that we created a couple episodes back and we brought it right up to the e-stop button. So the robot's about to self-destruct here and kill his own power source, virtually, of course. Free to go back to those other episodes if you missed any of them and catch up. So here, I'm just going to, on this episode, sort of get into, how you would work through the rest of some sort of operation we're doing here. I'm just kind of goofing around with the robot for now, but, this may as well be a real thing it's doing or a bolt it's putting in or whatever. So I hope that everybody can draw those same conclusions, of course. But so we've got our new point here, and we can move from here, which is target 10. We move in, and we get ready to push the button. So what we need to do is actually push it. And so, something like this, what I like to do, at least in ABB land, is to do a relative move. We'll come into rapid here, and I'll open up my push e-stop thing. So what he does here, this is really the end, so I'll just leave a comment, go home. And this one, start at home, go to button. So I don't, typically you wouldn't put a ton of these things in here, but it's always nice to comment your code. So we're going to move linear to the e-stop button, but let's push the e-stop now. So let's do this, and what we can do is actually a rel tool, and what this is a make a displacement relative to the tool. So I find this super useful. I know there's got to be a FANUC and KUKA equivalent of it, but it basically says, like, if you don't have a coordinate frame for what this is, I mean, we're really moving in world X in this case, but often you'll, especially on irregular geometry, you're not going to be able to just move in one direction backwards. So rather than putting a separate point in the e-stop, which would be I don't know, a little odd to teach, I guess, and you find good reasons for this, so I'll demonstrate it. But let's go ahead, while I'm thinking about it, kick that up to high speed, or maybe V500. We'll get us half a meter a second, and then we'll push it nice and slow. So what we want to do is rel tool. We're still in the middle of this command. This is the number in X, or the delta X rather, the delta Y, the delta Z, of your tool coordinate system, and so you can actually move with respect to that tool in any of those directions. So Z, if this is my tool, would be in and out, up and down, left and right, and then you can actually rotate about those same axes, like we talked about a long time ago in one old episode. So it's pretty cool, but you have to specify these first three. That's what it's saying, and then the last three are optional. You can specify. So maybe I can demonstrate those, but so I want to move 0 in X, 0 in Y, and then I think that would be about positive, we'll go kind of far just to make sure we see it, 25 millimeters. And then what we'll do is really, we just want to rel tool back out, but we want to come out away from it. And for that matter, that point is right on the e-stop. We'll leave it. But I'll rel tool negative 50. Come out nice and fast at maybe 500 as well, and then I'll go home. So let's try that. Let's see what this does. Oh, that dialog said, hey, this is going to destroy your program pointer, which is saying, the robot sort of knows where it's at in the program. You can stop and start, which really is more of a pause. So typically I try to write my code where the program pointer is not all that important. You can start from anywhere and get to anywhere in the program, but that's a lot more in depth than I'm probably going to take this series. So, okay, here we go. We now have motion. So did we synchronize that to the station? I don't remember. Let's do it just to be safe. Keep everything in sync, Okay, joint out of range. Why did we get that all of a sudden? Does some odd stuff here. Start from here. I'll get into configurations a little bit. Well, actually, you know what? I'm going to get into configurations now to fix this problem. Alright, so our robot has forced us to learn about configurations. Basically, configuration means, if you look at this first point, let's get this all turned off so we can see what we're doing here. This robot has over 360 degrees of rotation in this joint that you're seeing here, as well as this joint. In addition to that, that's one complexity. In addition to that, the robot can reach this exact configuration from multiple ways, and it depends really on where the target is. But if you come here and you go to configurations, I've got 4 choices here. So it's saying basically the robot can get to this exact orientation with this tool in 4 different ways. So let's see what they are. You click the first one, it's the one we're at right now. So that's fine. Click the second one. What happened? This wrist, let me zoom in. This wrist changed around. And it's kind of silly the way, since I have this view tool at target thing turned on, it sort of goes real quick. But it's basically switching the 2 sides. So I can apply it, boom, that's the other way. So since this wrist can flip all the way around, and this can rotate, and this can rotate, it will do different ways to get to the exact same point. The robot's different, but the piece is in the exact same position in all 6 degrees of freedom. So another funky one I can do is this one. And so he's actually flipped this all the way around backwards from here. It can do this goofy stuff. And so this is, this is an invalid configuration. You're not going to flip this axis all the way around and then flip this all the way upside down. I don't think it can even do that, but you're going to crash trying if you do that. So avoid that. But essentially what you do is pick a configuration that works. And so then your target then goes from this warning target to a solid target. And actually, I'm noticing another problem that we had is we were jumping from one work object to another with a linear move. That's sort of a bad idea because these configurations can't adapt. The robot needs to get there, and if you're doing a linear move, you're sort of locking that configuration in, and you don't really want to do that. You want to let it do a joint move anytime you can to let it sort of handle its own configurations. I think I need to go into a whole another detailed video on that maybe, but it's something that you get used to dealing with. So here, let's fix this work object problem here in a moment, but it is valid to have to go from a world object to a work object. So I'm going to try to fix that right, but let's get this configuration in a better state. So what you can do here, it doesn't like these rel tools, which is really annoying that they do it like this, but it doesn't really know about them. So over here in the station, it's like, I don't know what a rel tool is, I'm confused. So what you can do though is when you first get this target happy, let's see, this is work object 1, that's work object 0. So you can come here and do configurations, auto configure, and there you go. He kind of did it real quick, and I can do configurations. Let's see, I'll zoom in on it. Configurations, verify configuration, and boom, he's happy. And there you saw there's not an excessive wrist motion or it flipping around all crazy doing weird stuff. So that looks good, and we can synchronize that to rapid. And what it'll do is hopefully we can come in here and see that our configurations have updated how we want them. Have they done that? Yes. So they're defined here, whereas before they were undefined. So if they're undefined or zeros, it'll do its best to get there, but you're not really guaranteed any sort of orientation. So if somebody jogs it to a funky place, it'll try to go to that point, but the risk could be 90 degrees out from, or 180 degrees out from what you expect, and bad stuff happens. So while we're at it, I'm going to change this in my system here. I can move joint here, move joint here, and I forgot I had to delete my relative moves. You don't have to delete them, but it's usually best to do the auto configuration before you go in and tweak all these paths, but I sort of forgot. So we're going to go 25 in and then 25 out. And actually, I'll introduce another thing real quick. We don't want to we're going to get overridden by these zones here. So like we want to make sure that we go fine on that one. This one's a exit zone, so it's actually could go bigger. Maybe Z50, something like that. This is our nice slow one, by the way. Might be V20. So what I'm trying to get at here is you want to wait on the robot to get there. So you would do wait rob / in position. And you can say here's 0 speed, I want to say. Wait rob / 0 speed. Or you can do in position. But in position is what I usually use. So he's saying wait until he gets to this fine point and then carry on. Now this is a little bit redundant here actually, but picture you may do something once you're here. So I would maybe do turn on light or turn on spindle, something like that. And if you don't wait on the robot to get there, it's going to start processing this next line here based on its zone data. So as soon as it gets into that zone, actually it's already going to be looking ahead. And if you're flipping a digital bit that says like I just pushed the button or whatever, it's going to zoom past there. So you want to just wait and say, as soon as this robot's in that position, then it's time to get going. So let's see if this will work, and then we can move on to something else, finish this video up. Let's apply those changes. Let's see what happens. Alright, he's cruising. What have I done? I can come here, check, follow, or rather go to motion pointer. I left him at V20 for going to the button, and then of course, rel tool 25. Ah, Lord, I messed something up. But that's okay. We'll watch him go. Come on. Dun, 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 dun. No, I can't stand it. Let's stop it, fix it real quick. So this one, I changed it instead of adding one. So let's ditch this. Ditch this. So we'll go to the point. We'll go there at 500. We'll easily push in, or very gently push in. No torque control, so it'll go right through it. If you tell it to go, 500, it'll just push and push until it torques out. But then we'll come back quick, and then we'll go. Let's try that bit. Let's see if that works better. Start. He's starting. Dun, dun. Oh, he's pushing the button, and then he zoomed back out. I don't know what that was at the end. Maybe I did something crazy in here, but I put it down below. That's where it was that whole time. Fix it. Yes. Home. Play. Push that button. It would have e-stopped there if it was a real robot, but you get the gist of that, I hope. This is a joint move. Let's watch it go one more time. Was that a linear move? Oh, come on. Push e-stop. Is that program pointer driving me nuts? Okay, so we changed that to a joint move just to reiterate this for one last thing. See, he's not quite going down that path, so he's going as quick as the joints want to go. He's letting them make their own path between these 2 points. So, yeah, that's about it. After this, we will go on and move that work object around and maybe trigger a few more things, talk about recovery, and I'll be done after that.